Hey everyone, welcome back to the channel. For the past 20 years, we've been told a pretty consistent story about our universe. It's expanding, and not just expanding, but accelerating. The culprit, a mysterious, invisible force called dark energy, which supposedly makes up nearly 70% of everything that exists. It's the ghost in the cosmic machine, silently pushing galaxies further and further apart. This idea is a cornerstone of the standard cosmological model, the framework we use to understand the cosmos on the grandest scale. But what if that cornerstone is starting to crack? What if dark energy, this dominant force, shaping our universe's destiny, is actually fading away? It sounds like science fiction, but recent groundbreaking research is suggesting just that. A new study, analyzing a vast amount of cosmological data, has uncovered evidence that dark energy might not be the constant force we always assumed it was. Instead, it seems to be weakening over cosmic time. Now, in science, you can't just make a claim like this without serious proof. The statistical significance of this finding is what scientists call 4.2 sigma. To put that in perspective, a 5 sigma result is considered the gold standard for a discovery. So, 4.2 is incredibly compelling. It's a signal that is very, very hard to ignore. If these findings are confirmed, it wouldn't just be a minor tweak to our theories. It would be a seismic shift, shaking the very foundations of cosmology and forcing us to rethink everything we thought we knew about the universe's expansion and its ultimate fate. Of course, extraordinary claims require extraordinary evidence. Science is all about skepticism and rigorous testing. So, right now, teams of scientists all over the world are in a race against time. They're designing new experiments, scrutinizing the data, and trying to replicate these results. Is dark energy truly weakening? Or could this be a subtle error in the measurements, what scientists call a systematic error? Maybe it's not an error at all, but a sign of brand new physics we haven't even dreamed of yet. Or, perhaps most radically, it could mean our entire model of the cosmos is wrong and needs a complete overhaul. The stakes couldn't be higher, and the global scientific community is buzzing with excitement and debate. And the cosmic mysteries don't stop there. While we're questioning the nature of the universe on a massive scale, we're also delving into its strangest behavior at the tiniest scale. I'm incredibly excited to announce a special live event we'll be hosting, featuring the brilliant Dr. Meetha Yoganathan. She LLB diving deep into one of the most mind-bending concepts in all of physics, quantum entanglement. Einstein famously called it spooky action at a distance. It's the bizarre phenomenon where two particles can be linked in such a way that they instantly affect each other, no matter how far apart they are, whether it's across a lab or across the galaxy. Dr. Yoganathan will explore how this strange connection isn't just a quirky feature of quantum mechanics, but a fundamental aspect of reality. More importantly, she'll discuss how we're harnessing entanglement to build the next generation of technology, quantum computers. These machines promise to be revolutionary, solving problems that are impossible for even the most powerful supercomputers today. So, make sure you join us for that live event. It's going to be a fascinating journey from the weirdness of the quantum world to the future of technology. Now, how do we even measure something as vast and abstract as the expansion of the universe? It's a great question. Cosmologists are like cosmic detectives, looking for clues left over from the very beginning of time. One of their most powerful tools is studying the echoes of the Big Bang. Think of it like this. In the hot, dense early universe, there were ripples, like sound waves, traveling through the primordial soup of matter and energy. These waves, called baryon acoustic oscillations, left a faint imprint on the distribution of galaxies we see today. They created a kind of standard ruler of a known size in the early cosmos. By looking at how large this ruler appears at different distances and different times in cosmic history, scientists can measure the expansion of space with incredible precision. They combine this standard ruler measurement with another crucial piece of evidence, redshift. As galaxies move away from us, the light they emit gets stretched out, shifting towards the red end of the spectrum. The faster a galaxy is moving away, the greater its redshift. By combining redshift data, which tells us speed, with the standard ruler data, which tells us distance and scale, researchers can piece together a history of cosmic expansion stretching back billions of years. This powerful combination allows them to test different theories. Does the data fit a universe with constant dark energy? Or does it better match a model where dark energy is fading? Each new telescope, Each new survey of the sky adds another data point, bringing us closer to the truth. We're essentially cross-examining the universe itself to see if its story holds up. This all brings us back to the profound questions raised by this new research. If dark energy is indeed fading, what happens next? The implications are staggering. Will the universe's expansion begin to slow down? Could it eventually grind to a halt? Or could it even reverse, leading to a big crunch, where everything collapses back in on itself? It's a complete rewrite of the universe's endgame. Alternatively, what if this isn't a sign of fading energy, but the first hint of a completely new force of nature, a fifth fundamental force we never knew existed? The possibilities are as exciting as they are unsettling. We are standing at a pivotal moment in our understanding of the cosmos. This journey through cutting-edge cosmology, from the grand scale of the universe to the spooky realm of quantum mechanics, reminds us of something fundamental about science. It is never finished. It's a living, breathing process of questioning, testing, and discovery. The answers we find today often lead to even deeper, more profound questions tomorrow. What we are witnessing is not a failure of our models, but the very essence of the scientific process in action, the relentless or inspiring human quest to understand our place in the universe. We are living in an incredible era of discovery, and the cosmos, it seems, still has plenty of secrets to reveal. Thank you so much for joining me on this deep dive into the frontiers of physics. If you found this as fascinating as I do, please hit that like button. And if you haven't already, subscribe to the channel and ring the bell so you don't want to miss our upcoming live event with Dr. Yoganathan and all our future explorations into the biggest questions in science. We've got so much more to explore together. See you in the next video.